This is part 3 of the things to memorize by heart video. This is oxidation and reduction. So first of all, you need to know the definition of oxidation and the definitions for reductions. Okay, so there are 4 definitions. For example, you could be asked questions like state the 4 definitions of oxidation. So there will be gains of oxygen, loss of hydrogen, loss of electron, increase in oxidation state. So these are the 4 definitions for oxidation. And then you need to know the definition for redox reaction. So a redox reaction is a reaction whereby oxidations and reductions are taking place at the same time. So oxidation state basically is the same with the charge of an ion. Oxidation state of free elements is 0. So this part you need to know as well. Okay, then we go to the oxidizing agent. So you need to know that oxidizing agent oxidizes other substance and it itself gets reduced. Okay, these are the common oxidizing agent. So you have to remember this oxidizing agent. Basically, it's a halogen, concentrated sulfuric acid, oxygen. Of course, oxygen is an oxidizing agent, and especially these two, potassium manganate 7 and potassium dichromate 6. Okay, so these oxidizing agents you need to remember. And then in order to test for oxidizing agent, we need these 2 reducing agents. These 2 are the reducing agents. And you need to remember the color change. So for example, aqueous potassium iodide, when it is used to test for an oxidizing agent, and when the oxidizing agent is present, there will be this color change from colorless to brown. And then for moist starch iodide paper, the color change will be from white to blue. So these 2 reducing agents are used to test for oxidizing agent. Okay, reducing agent, these are the list of reducing agent. Okay. And again, for reducing agent, it reduces other substance, it itself gets oxidized. And likewise for reducing agent, in order to test for reducing agent, you need to use oxidizing agent. So it's mainly these 2. So these 2 are basically the same with these 2 that I asked you to remember just now. And you have to remember the color change. For the metals chapter, first of all, you need to know why pure metals is soft, because the atoms, so the first point is atoms are of the same size, and the second point is they are packed tightly in layers. So that is so when a force is being applied to the pure metal, the layers of atoms can slide over each other. Okay, so 3 key points here. Atoms are of the same size, packed tightly in layers. When force is applied, layers of atom can slide over each other. So this explains why pure metal is soft. And likewise, why alloy is stronger than pure metals. It is because of this reason. 3 key points here. Atoms of different elements are of the same sizes, arrangement of atoms irregular, and layers of atom cannot slide over each other. So there are 3 key points why alloy is stronger than pure metal. And you need to know the composition of the alloys that I put a thick. Brass, you need to know the composition. Stainless steel, 4 constituent elements. Steel, 2. Bronze, another 2. And over here would be, why do metals conduct electricity? This is actually the same with the bonding chapter under metallic substance. So why metals conduct electricity? Because due to the tightly packed atoms, outermost electrons of metal atoms can break away easily from the atoms. And the positive metal ions, so the result would be positive metal ions surrounded by sea of mobile electrons. So you have positive metal ions here surrounded by the dots here, which are the delocalized electrons, and the mobile electrons can carry charges and transfer heat. So this, again, 3 key points why metals can conduct electricity. Then after that, you need to know the reactivity series, including aluminium. And for the reaction of metals with cold water, steam, and HCl, you need to know that for reaction with steam and HCl, you have to remember the last element that react with steam and HCl, they are the same. The last element would be iron. Okay? And for cold water, the last element that react with cold water is calcium. And you need to know zinc oxide is yellow when hot, white when cold. In the QA, you should have done this. And the reactions involving metal, you need to know. Again, this is similar to the chemical reactions and chemical equations mind map. Okay, these 3 reactions are in the chemical reactions, are in the chemical equations mind map. So you have to remember them. Okay, this is reduction of metal oxides. So you need to know that carbon and hydrogen are reducing agent. So they can be used to reduce oxide into the metal. For example, reduce means remove the oxygen. So if you heat carbon with an oxide, with a metal oxide, the oxygen will be stripped from the oxide and give you the metal. So therefore carbon is reducing agent. And you need to know what are the oxides that can be reduced by carbon. The first oxide that can be reduced by carbon would be zinc oxide. Okay? And the first oxide that can be reduced by carbon is iron 2 oxide. Zinc oxide can, with hydrogen. Zinc oxide cannot be reduced by hydrogen. Remember that. Displacement reaction. Okay, a more reactive metal will displace a less reactive metal from the salt solution. Metal oxide and another metal, so this is quite similar with the displacement reaction. A more reactive metal, in this case is zinc, will displace a less reactive metal, which is copper, from its oxide. And the thermal decomposition of metal carbonate. So when you heat carbonate, you get oxide and carbon dioxide. And all carbonates will decompose when being heated except potassium carbonate and sodium carbonate. Okay, all these carbonate, calcium carbonate, magnesium carbonate, all these when you heat them, they will decompose into metal oxide and carbon dioxide. And then for silver carbonate, decomposes into silver and carbon dioxide on heating. Not silver oxide and carbon dioxide. It's silver and carbon dioxide. You don't get silver oxide here, because silver is simply too unreactive. Okay, so the more reactive, this part is very important, more reactive metal, they form more stable compound. An example is potassium carbonate. Potassium is very reactive, so it forms a very stable compound called potassium carbonate. And because it is very stable, this potassium carbonate, it is very difficult for its compound to decompose upon heating. Very difficult for potassium carbonate to decompose, and that is why potassium carbonate doesn't decompose. So the first 5 elements, they can be extracted by electrolysis of molten ore, and the subsequent elements, reduction with carbon of metal ore. You need to know which are the elements that can be extracted by electrolysis, and which are the elements that can be extracted by burning it with carbon. Extract iron from hematite. These 5 reactions must remember, must know the explanation as well as the chemical reactions. All 5. Okay, for rusting, the different rusting method. Next would be for periodic table. You need to know same period means what? Same number of electron shells. That is same period. Same group means same number of valence electron. And if they have the same number of valence electron, that means that chemical properties would be similar. So I have to remember that. And then you need to know the trend. As you go down a group, what happened to the proton number? What happened to the size of atom? What happened to the metallic properties? And when you go across the period, what happened to the metallic properties, non-metallic properties, and the size of atom? So the trends you must remember by heart. Periodic table chapter, you need to know group 1. Group 1 metals are also known as alkali metals. Why? Because they react with water to form alkali and hydrogen. And then you need to know the physical and chemical properties as well. And group 7 metals, group 7, they are also called halogens. And you need to know their color, the states as well as the color. Okay, states are gas, gas, liquid, solid, solid. Color, pale yellow, greenish yellow, reddish brown, purplish black, and black. You need to know that. Now for energy chapter, basically you need to know exothermic, the definition for exothermic. Heat is released to the surrounding, and then what happened to the surrounding temperature? What happened to the delta H? Delta H, or the heat change, is it positive or negative? The products have less or more energy than the reactants, and the energy for bond breaking is greater or less than the energy for bond making. So for exothermic, you need to remember these 5 things. So I'll probably ask you, for example, delta H for exothermic, is it positive or negative? So you have to remember that. Likewise for endothermic here. Okay, example of reactions for exothermic. Combustion, when you burn something, definitely it will give out heat. Rusting of iron also, it will give out heat. Neutralization, respiration. And then for endothermic, photosynthesis and thermal decomposition. So these examples you have to know. So for example, neutralization, you should straight away know that it is an exothermic reaction. Speed of reaction. Speed of reaction, you need to know the definition for activation energy. Minimum amount of energy that reacting particles must possess in order for a chemical reaction to occur. That is called activation energy. And then you need to know how the speed of reaction can be increased and why. So the factors affecting speed of reaction, there are 5 factors you need to know. For example, increasing concentration, increasing temperature, increasing pressure, decreasing the particle size, and using catalyst. And why? For example, you could be asked, why increasing the concentration, speed of reaction will increase? So these are the reason. So for each of these factors, you need to be able to explain why speed of reaction is decreased or speed of reaction is increased.